Hi everyone, so we're going to start some new notes. So please make sure that you have a notebook in front of you and a pencil because you're going to want to take some examples down and I'll tell you which ones to write down. But we're going to split this part of the notes into two different parts. So we're going to be multiplying properties of exponents. Here are our standards and objectives. You're going to be able to multiply monomials using the properties of exponents. So you're going to simplify expressions using the multiplication properties of exponents. This you do not need to write down. It's just an overview of what you're going to be learning today. Just a really quick review on what an exponent is. So in an expression of the form x to n, the exponent is n. So the exponent is the small number up in the right corner. It indicates the number of times x is used as a factor. So for example, if we have 3 squared, we know, because we've talked about this a million times in class, that 3 squared is not 3 times 2. Okay, this right here is my exponent, and this 3 right here is my base. So whatever is your base is, you need to multiply it by itself however many times your exponent tells you to. So in this case, my base is 3, and I have to multiply it by itself twice. So I'm going to have 3 times 3, which will get me 9. So 3 squared is 9. This is something that you guys are familiar with. We've used it a few times in class already, but it's just a really quick review on what an exponent is because we're going to be working with them. So for monomials, and this is something you're going to want to write down, so take a second to write down the definition. Pause this video if you need to. Monomials is a number, a variable. Remember, a variable is just a letter. Or a product of a number and one or more variables. So any numbers and variables multiplied together are going to make monomials. So once you finish writing that definition down, I'd like you to write down these three examples of monomials. So my first example is 3y cubed. Notice that my 3 and my y are being multiplied and I have my exponent here. So that is one example of a monomial. Again, please write these examples down. Another example is 7 times x squared times y cubed times z to the first. Another way to write this z to the first is just by writing z. You can keep that 1. It can be there or it can't be there. It means the same thing. So notice that the 7, the x, the y, and the z, they're all being multiplied by each other. There is no multiplication symbol showing that, but the fact that they're all together in a row shows that they are. And then my last example of monomial would just be any number. So 12, 100, 1000, any number whatsoever. So I'd like you to write these 3 examples down. You can also, I'd like you to take a second on your Ed puzzle and give me your own example of a monomial. So go ahead, take a second and submit that for me. Once you've submitted that, I'm going to give you some examples of expressions that are not monomials. So I'd like you to take these down in your notes as well. So my first example is 5 plus x. This is not a binomial because there's addition happening. If there's any addition or subtraction happening in your expression, it is no longer a monomial. A monomial is just one expression. Whenever you have 2 divided by a variable, so any number divided by a variable is not a monomial. You cannot have a letter or a variable in your denominator. Another example of non-monomial is 4 to the a, or that's literally how you say it, 4 to the a. You cannot have a variable or a letter in your exponent. You cannot have a variable as an exponent, so that would not be a monomial. And you also can't have a negative exponent. That would also make this a non-monomial, so be careful with those. So take a second, write down these examples, and then real quick in your Ed puzzle, I'd like for you to just write your own example of what a non-monomial would look like. Again, that can be anything added together, anything subtracted, any number over a variable, any number to an exponent that's a variable, or anything that's to a negative exponent. So we're going to be identifying monomials. So I'd like you to take a second and write this first example down, 17 minus c. And I'd like you to, in your Edpuzzle, determine if 17 minus c is a monomial or not. 17 minus c is not a monomial because the expression involves subtraction, so it has more than one term. Take a second, look at my second example B. I'd like you to write this down in your notes, and then I'd like you on Edpuzzle to determine whether this is an example of a monomial or not. This expression is a monomial because they're all being multiplied. 8, f squared, and g, these are all being multiplied together. So it makes one expression, so we do have a monomial. Write your next example down, 3 over 4, and determine whether this expression is a monomial. And submit that into Edpuzzle. This expression is a monomial because it's considered a number. 3/4 is a number. One of our previous examples was just 12. That's a number. So 3/4 can also be written as a decimal, which is 0.75. So this is considered a monomial. Take a second and determine whether 5 over t is a monomial. Again, guys, make sure you're writing this all in your notes. And submit that into Edpuzzle. 5 over t is not a monomial. You cannot divide a number by a variable. All right, guys, so we're going to be multiplying exponents and variables together. So whenever you're multiplying a variable that has exponents, you're going to add those exponents together, okay? So you have to have the same base, so these both need to be a, and you're going to end up adding these numbers together, whatever they are. So just a few examples. B to the third times b to the fifth. I'm going to add my exponents together, and I'm going to get b to the eighth. G to the fourth times g to the sixth. I'm going to add my exponents together, and I'm going to get g to the 10th. Take a second, guys, pause the video, please, and write this down in your notes. So we're going to see what happens with these 3 examples. Again, make sure you're writing everything down. I'd like you to write these 3 examples down in your notebook. Pause this whenever you need to. So my first example here is going to be x to the 6th times x to the 3rd. Now, when I have the same base here, x and x, they're the same, they have like terms. So what I'm going to have to do is I'm going to have to add my 6 and my 3 together. So I'm going to keep the base the same, and I'm going to add the exponents. So if you see, I'm going to have x to the 6th plus 3, which is then going to become x to the 9th. My next example, I have x to the 4th, y to the 5th times x, y to the 3rd. You're going to keep your x's together, and then you're going to keep your y's together. So I can't combine 4 and 3 because my bases are x and y. They're not the same. So I have to keep my x's together and my y's together. Notice that this x doesn't have a number next to it. It's because there's a 1 over here that we cannot see. So for this example, you're going to combine your like terms and you're going to add your exponents. So for my x, I'm going to add 4 plus 1, and I'm going to get x to the 5th. And then for my y's, I'm going to add, this is a typo, this should be 5 plus 3. So I'm going to add 5 plus 3, and I'll get y to the 8th. Sorry about that, guys. So make sure when you're writing this in your notes, this is y to the 5 plus 3, not 5 plus 1. My last example here is r to the 4th times negative 12 r to the 7th. So whenever you have just constant numbers in the front, you're going to keep them. So there's a 1 in front of this r that we don't see, and we have a negative 12 here. So it's going to act like 1 times negative 12. And then because my r's are the same letter, I'm going to add my exponents together. So I'm going to combine my like terms, add my exponents. So I'm going to multiply 1 and negative 12, which is going to get me negative 12. And then I'm going to add my exponents for r because they have the same base, and I'm going to end up with 11. So my final answer is negative 12 r to the 11th. I know we went through that kind of quickly, so please make sure you're writing everything down. Pause the video if you need to, and just know that if you have any questions on this when you're doing some practice problems on your own, I am just an email or direct message away. So here we have another example. This one's a little more complicated. We have Einstein over here, who literally, his equation that he created, E equals mc squared, that mc squared is actually a monomial. So our first step here is we want to combine all of our like terms. So we're going to keep our constant numbers with our numbers, our c's with our c's, and our d's with our d's. So again, make sure we're writing this down in our notebooks. Step 1, we're going to multiply 6 and 5. We're going to multiply c times c to the 5th, and we're going to multiply d to the 5th times d to the 2nd. Remember, there's a 1 here that we cannot see. So you're going to be adding 1 and 5, and for your d, you're going to be adding 5 and 2. So for my next step is just showing you that. So 6 times 5 is 30. C times c to the 5th becomes c to the 1 plus 5. And then d to the 5th times d to the 2nd becomes d to the 5 plus 2. And then finally, just simplifying everything down, you're going to bring your 30 down. 1 plus 5 becomes c to the 6th, and then 5 plus 2 becomes d to the 7th. So again, if you need to pause this and take these notes down, please do so. Here's some examples that I want you to try on your own. So we have 5 to the x squared times 4x cubed. I want you to take a second, and these are multiple choice, so you're going to pick either A, B, C, or D and submit your answer to me on Edpuzzle. I suggest you do your work on a scrap piece of paper. Remember, keeping your numbers together and your bases with like terms. Same thing for my second example here. This one's a little more complicated. Just take a second, try to do this out on your own, and then select what your best option is going to be for your answer. Again, guys, if you have any questions, please reach out to me via email or direct message me on Google Hangouts. I'll be giving you practice problems soon to try on your own. This is just the first part of this section, so I'd really like for you to get as good of a grasp on this as possible. If you need to rewatch the Edpuzzle and retake notes, feel free to do so. I hope you guys have a wonderful day.